Hello everyone, I hope you are doing well. In the previous video, we solved problem 189 together, but the execution time of that solution was n power of 2. It was a huge number. In this video, I'm going to show you how by increasing the space complexity, we can reduce the time complexity of that method. So this was the solution that we had previous time. Okay, wait. And we want to increase, if just assume that this one was space complexity, this one was time complexity. I want to increase the space complexity, for example, to something to On, and see can I reduce the time complexity from n power of 2 to something like On. So let's see what we could do to solve this issue. So I'm going to remove the previous implementation and I'm going to show you how we can achieve our goal. So let's see what we can do here. Okay, each time let me draw. Why it's not working? Oh, it's working now. The array again. This is the array 1, 2, 3, 4, 5, 6. The first item of the array is in index 0, the second index 1 until I get to the end. If I rotate this array 3 times, each time one step to the right, I will get to the array like this. 4, 5, 6, 1, 2, 3. For the k equal 3, that I rotate the array 3 steps to the right. So let's see what changes we have here. For example, the item that we had, the first item that we have was 1, 2, 3, 4, 5, 6. The first item was in index 0, the second was in index 1, and the last item was in index 5. But after we rotate the array 3 times, each time one step to the right, the first item that was 1 index 0 moved to the fourth space that we have in the array, moved to the space with the index 3. The second item moved from the index 1 to the index 4, this one to the 5. But the fourth item that we have here moved from the index 3 to index 0. And the last item that was 6, that was in index 5, moved to the index 0 here. Sorry, index 2 here. So if we check just these 2 columns, we can see a relation between these numbers. Think that I defined each indexes with I, and we have a k here. So assume that I is index of each item. K is the number of rotation, and NB length of array. If I write the formula like this, then I have I here, I add k to the I, and then find the remaining of this value to the length of the array. Let's test this formula with this item. For example, if I put the I that we have here with the index 0, we know that the k is 3 and the length of array is 6. What we will get here, the result will be the 3. So 0 changed to 3. If I use the index 1 and do the same things, the result will be 4. But if I use the, for example, the item 4 that is index 3, oh, the remaining is 0. We get to this point, or the last one. Oh, last one is index 2. Oh, this is 3. So this is the 8. Then we get to the index 2. So this formula works for us. So by just rotating through the array one time and just calculating the new location of each item, we can easily, with the order of n, we can solve this solution. But this solution has one problem. Each time that I calculate the location of for example, each item and move the item, I overwrite one of the existing items. For example, if the array be like this, for the first item, I do the calculation. I found, oh, first item need to move to the index 3. So I move the first item to the index 3, 0, 1, 2, 3. So I remove the 4 and put 1 here. So I will lose the 4. At the time that I want to move the 4, I don't have the value of the 4 here. So I need to copy this array somewhere in the memory and just iterate through the cloned version of the array and then move the items. For example, move this one to here, then move this one to here, this one to here, and then to here, to be able to solve the problem. So I need to assign the same space like the initial array that we have in the memory to be able to solve this issue. So by defining the new array, the space complexity move from order of 1 to order of n, but the time complexity reduced from n power of 2 to n to the order of n. So let's jump to the code and see how we can implement this solution. So let's define the new array, and I name this array as a result, and this array equal to length of this array equal to the length of the initial array that we received. Okay, we defined a new array. So what I want to do here, I need to iterate and visit each item of the array one time and move the item from the index I to the new index that we will calculate for the array. So I have an array here. I need to visit all items of the arrays. One time, and each time that I'm visiting that item, I need to move that item to the new location. So what was the formula? The formula was like this. So I just define new index and as I show you, the formula was something like this: I plus k reminded by n, and n was nums that length. So if I just set the result new index equal to nums I just moved that item from the previous location to the new location by calculating the index of the new location. So then after this loop get n, we have a new array that array contain all the items in the correct location after we iterate or just move each items one step to the right for the k times, but we need to have the result in the array that we name nums that we received as the input. So I need to copy the array with the name result to the initial array that we have. So I need to have another array just to copy the result array to the initial array. Okay, let's run this code and see everything is correct. Okay, sorry, I made one mistake here. I should not put this one here. I should iterate through all the items of the array. Okay, so that solution is work. So let's submit this solution and see what we will get in the result when running this solution with the too many items in the array. Oh, as you see, our solution worked. So, and here we have some statistic value, but by increasing the space complexity, we achieved to reduce the time complexity. But is there any other solution that we can solve this problem by space complexity of order of 1? So to see is there any solution or not, please follow me on the next video. Thank you.